Alright, good morning. My name is Jayson van Rooyen, and I'll be presenting our electronics course design project for the term. So we plan to make a maximum PowerPoint tracking device. Yeah. You can use it with solar panels and wind turbines. Here's our project description. So this device was supposed to be used like for camping trips or outdoors, obviously, since it's a solar panel. And we also wanted to incorporate a weather station in it so we can measure like the wind speed or the temperature or the humidity. And we wanted to have like time of day on our LCD display as well. Here's our problem statement. So to build and program an MPPT charging system that can be used to charge cell phones or any USB device. That's another thing we wanted to do. We wanted it to be able to like output 5 volts so we can charge cell phones. Anyway, well, since it's USB, you can charge more than that. So we needed to do some research for many of our components. We had to have the correct voltage ratings and current ratings so nothing blows up.
Yep.
Here's a picture of our wiring diagram. We didn't make this whole diagram by ourselves. We modified it to suit our needs, but we got the main part of it from Project Hub.
Oh, right.
Yeah, we painstakingly drew the whole thing with Sharpies and rulers. This was like our blueprint for the whole project. It was very important to us. It served as a roadmap to the finish line of the project.
And you kept to like wiring color conventions.
Huh?
You kept to wiring conventions.
Yeah.
Go make it nice and colorful.
So it took quite a bit of time for us to receive all of the parts we required. We actually wanted to make a wind turbine at first using a car or a motorcycle's alternator. We spent so much time at the workshop testing like a wide array of different motors to see what kind of power they produced. But we abandoned this idea entirely and decided to opt for solar power instead. Less moving parts and no hassle with choosing a motor. Plus, we would have needed to build quite a large turbine in order to produce some actual torque to turn a large motor. Yeah. Since you're at ground level, wind speed is quite low. You're not going to be turning anything very quickly. So, yeah, that's why we opted for solar panels instead. A lot of work went into the first build. Unfortunately, it was extremely messy, looked like a rat's nest, and I made some errors in the construction, so we needed to completely disassemble it. I also misread our diagram, so I had the symbols for non-polarized and polarized capacitors mixed up.
Well,
Any boost more?
No.
Good question.
So an important lesson I learned is the difference between those two symbols.
wait, so like which one is it on the capacitor? Because I know sometimes they've got like a strip.
That's non-polarized, that's polarized, so this will be the one.
Thank you very much for that. How do you identify that on the actual?
Wait, say that again?
It's the one, this would be the ones with the short and the long
short
leg and the
leg,
little stripe on the
okay.
short leg to indicate the negative. And then non-polarized ones are like the, what do you call it? Mylar?
Can we maybe leave the questions for last, otherwise it eats into their time.
So, our shortcomings. We had big plans for this project. We wanted to measure wind speed, temperature, humidity, and the time of day to be displayed on an LCD. We never we never got around to that, and it's just really disappointing to me. Maybe if we had our parts earlier, there would have been more time, but there's no use in dwelling on that matter. We plan on having a smart charging station for camping trips or when we're out in the world.
Ooh.
So this is what it looks like now. It's the second iteration. It's very cool. It's much neater and there's no missing parts except for a IO expander. We weren't able to test whether the circuit actually works, but if we followed our diagram correctly, then I'm sure it would. It just needs to be programmed. All the connections are making proper contact. Yeah. Alright, so what's MPPT supposed to do? So, okay, this is a lot of reading.
Batteries can be used for.
So maximum power point tracking is electronic tracking, usually digital. The charge controller looks at the output of the panels and compares it to the battery voltage. It then figures out what is the best power that the panel can put out to charge the battery. It takes this and converts it to the best voltage to get maximum amps into the battery. Most modern MPPTs are around 93 to 97% efficient in the conversion. You typically get a 20 to 45% power gain in winter and 10 to 15% in summer. Actual gain can vary widely depending on weather, temperature, battery state of charge and other factors. I'm going to hand over to Raymond.
But with the MPP tracking, the algorithm is used for extracting maximum power from the PV model to operate at its maximum efficient voltage under certain conditions. The voltage at which the PV model can produce the maximum power is called MPPT. Right. MPP checks output of the PV model, it compares the battery voltage, then fixes what is the best power that PV model can produce to charge the battery and converts it to its best voltage to get maximum current into the battery. It can also supply power to the DC load, which is connected directly to the battery. Right, and this is our the materials, a few of our components, for example the AC is 0112 current sensor, and our buck converter and our LEDs and TVS diode. Our total from all the components that we purchased was $809.50.
There were also a bunch of capacitors, but the price adds up to like 40 rand.
Just disclaimer, this is not all the material parts. Unfortunately, I couldn't add all the parts.
Just the general.
Yeah, just the general.
Capacitors
over there. Right, and the roles and responsibilities for mechanical, James was more for the 60% for help assembling for the project. For the electrical, Jayson was more concentration for that, and also assistance with the electrical soldering. And unfortunately, with the coding, could not get any coding into all of the project. I'll explain that to that later. And for the documentation and administration, I was 70% and Jayson was 30%. For the project testing, during the process, we tested the voltage on the buck converter to see what voltage it will output to other connected components. We also tested the connectivity between the 12-volt battery and the solar panel if there was any power and connectivity that was for the current to be flowed between the connected components. And here are some pictures of how the whole project looks from the front view and the top view and the side view. For the time management, our time management on the coding was very poor. However, we could have a better planning on the mechanical and electrical phase. Also, we could also keep up to date with the PPT and our website. Here are some screenshots of our evidence for our activity log and some evidence of our data that we do have on our website, and also for Reflector concept here to keep up to date with JC for the PPT sessions. Our successes, we could complete for the mechanical and electrical phase of the project, and also for Jayson and I, we could improve our soldering skills for all the soldering of the wiring on the boards, and that was really quite fun. For difficulties, definitely for ordering the parts from a few shops took very long to arrive, especially like from Antec. I would not recommend them. Their services is very poor. Secondly, it was a challenge along the way to do the wiring on the boards. Although we had the wiring, to do the connectivities and the wiring, it was quite a challenge to see which connection we had to do. And thirdly, unfortunately, our concentration was too much on mechanical and electrical. Therefore, we faced the consequence that we could not have the time to complete the coding phase. For acknowledgements, I want to say thank you to James and Raymond for help assembling for the product in the mechanical field, and for Richard for the big assistance for the ordering and fetching of the components at the shops. For the lessons learned, to do better planning on time management for future projects, and secondly, to plan on ordering pods at an earlier stage so that it has arrived and that we can carry on with the next phases of the project. And for that, we want to thank you for listening for our project.
Very nice.